So this is a very typical question in the topic of Venn diagrams. So you're given that the number of elements in the universal set, that is 100 students are considered. 100 students in a class are considered. In them, the number of students who passed in English is 15, number of students who passed in maths is 12, science is 8. And the number of students who passed both in English and maths is 6, both in maths and science is 7, both in science and English is 4. And the number of students who have passed in all the 3 subjects is 4. If that is so, you're asked to find the number of students who passed in English and maths but not in science. And the number of students who passed in maths but not in science but not in English. That means the number of students who passed only in maths. And the number of students who passed in more than one subject. So these are the 3 things that are asked of you. So these 3 things can be very easily found by using Venn diagram. So let us draw the Venn diagram corresponding to this information. So you have a universal set which is represented by the rectangle. So you have 3 sets, A, B and C. A, B and C. Now, we know that the Venn diagram has to be filled from inside out. So first let us fill the number of elements, the number of students that fall in this area. So how many students have passed in both science, maths and English? So let us write this science, let us denote this by maths, let us denote this by English. So how many students are, we don't start from here, we start from here. How many students have passed in both science, maths and English? That is this region. So this region has 4 students, right? Next, so how many students have passed in science and maths? Science and maths, 7 students have passed. Already 4 students are here. So the remaining 3 students are here. So how many students passed in English and science? English and science, 4 students. So this whole intersection has 4 students. So already 4 students have come here. So there are no students here, 0. Next, how many students are passed in maths and English? There are 6 students. So this whole region contains 6 students. 4 students are already there. So the remaining 2 students are here. Now, what is the number of students who passed in science? Total 8 students. 7 students have already come. So you have 1 student here. Similarly, number on maths is 12. 9 has already been considered. So the remaining 3 are here. English, you have 15 passes. So 4 plus 2 is 6. You have 6 already taken care of here. So the remaining 9 comes here. And we know that the universal set has 100 students. But not all the 100 students have been accounted. So 9, 10, 16, 20, 22 students have been accounted. So the remaining 78 students have been unaccounted. That means the remaining 78 students are outside this set. So now you're asked to find the number of students who passed in English and maths but not in science. Who passed in English and maths but not in science. That means just English and maths. So English and maths you have 6 students total. But I don't want the students who passed in science. So you have 2 students. So this answer is 2. So the number of students who passed only in maths but not in science but not in English. So they have to pass in maths but they should not belong to science. They should not belong to English. So the remaining students, 3 is the answer to this question. So these are the number of students who passed only in maths, not in any other subject. So the remaining of them have passed. The remaining of them have passed in other subjects also. So the number of students who passed in more than one subject. So these students have passed in exactly one subject. This guy has passed only in science but not in maths and English. These guys have passed only in maths but not in science and English. So these three areas represent the number of students who passed in only one subject. I want the number of students who passed in more than one subject. That means the intersection students have passed in more than one subject. So this and this region have passed in exactly two subjects. This region students have passed in all the three subjects. So number of students who passed in more than one subject will be 4 plus 3 7 plus 2 is 9. So this will be equal to 9. So these will be the answers to these questions. So in this question you are given that out of 64 students, 45 students have passed in maths, 10 students have passed in maths as well as biology. The number of students who only passed in biology is equal to what? And it's given that all the students have passed either in maths or biology. There are no students who have failed in both subjects. So let us draw the Venn diagram corresponding to this question. There are only two sets, so if you draw the Venn diagram, so let us take that this set corresponds to the set M, this set corresponds to set biology. So the students present in this circle passed in maths, the students present in this circle has passed in bio. So the students who have passed both in maths and bio come in this region, right? Now let us fill the Venn diagram. So Venn diagram is always filled inside out. The number of students who have passed both in maths and biology is 10. So there are 10 students here. The number of students passed in maths is 45. 10 has already been there. In this complete set there are 45 students. 10 has already come here. So the remaining 35 are here. Now we are asked to find the number of students who have passed only in biology. This is being asked. And according to the given question, it's given that all the students have passed either in maths or in biology. That is N of M union B is equal to 64. So as you can very clearly see, this region plus this region plus this region corresponds to M union B. So 64 has to be equal to 35, that is M minus B, plus 10 plus X. X is number of students who are passing in only biology, right? So let us take this as X. So this implies X is equal to 64 minus 45 is equal to 90. There are 19 students who have passed only in biology. So in this question, you given that a college awarded 38 medals in football, 15 medals of basketball, 20 medals of cricket. So there are a total of 38 plus 15 plus 20. That is the total number of medals that are being distributed. And it's given that all these medals are being distributed for a total of 58 men. And only 3 of the men got medals in all 3 sports. If that is so, find the number of men who received medals in exactly 2 sports. So how do we do this? So what are the total number of medals that you have? So total number of medals distributed is equal to 38 plus 15 plus 20, right? 38 plus 20 is 58, 68 plus 5 is 73. Total of 73 medals have been distributed. And they have been distributed among 58 men. So out of 58 men, some men would have got a single medal, some men would have got 2 medals, and some men would have got all the 3 medals. So let us say that X got medals, X got single medal. So let us say that X men got single medal, Y men got double medals, and Z men got all medals. So X men got single medal, Y men got double medals, and Z men got all medals. And according to the given question, you're given that x plus y plus z is equal to 58. The total number of these men is equal to 58. This is the first equation. And the second equation is only 3 men got medals in all 3 sports. Z is equal to 3. So now with this information, can you find the number of men who got medals in exactly 2 sports? So I hope yes. So if you put z is equal to 3, you get x plus y is equal to 55, right? If you put 3 here, if 3 goes onto that side, you get 55. And the total number of medals have to be 73. So what are the total number of medals? Total medals given as 73, but according to this assumption, the total number of medals is x plus, because they are single medalists. So you have x medals going to these men. Y got 2 medals each. So 2 y medals have been spent plus 3 z medals have been spent is equal to 73. So z has been already taken as 3. So this implies x plus 2y is equal to 73 minus 9 is 64. Now you have one equation here, you have another equation here. So let us say that these two are equations 2 and 3. So if you subtract one from the other, you get y is equal to 64 minus 55 is. So y is what you're asked to find. That is the number of double medalists. So y has to be equal to 9. So this answer is 9. And how many single medalists? If you just put y is equal to 9, you get 46. So there are 46 single medalists, 9 double medalists, and 3 triple medalists.